So we have done adding and subtracting of polynomials. Now we are going to multiply polynomials, all right? And so the method that most people use for multiplying polynomials is called the FOIL method. It is really just repeated distribution. So if you think about what distribution is, so let's say I had some term out here and I am multiplying it through to maybe a group of terms, all right? If I were to do something like this, I would just distribute. What's on the outside distributes through, and we just multiply each piece by it, all right? So that's just distribution. And so we've done distribution, you just distribute the outside. But now we have not just one number out here, we have a binomial and a binomial. And so we are going to do repeated distribution. And they call it the FOIL method because of how this works. You're going to take this first term and you're going to multiply it by the first term, which is where we get first. First term by first term. And then you're going to take that first term and you're going to multiply it out to the second term. Well, these are both your outer terms. So these are your first terms. These are your outer terms, which is where we get our O. And now that we've done that with the A, we're going to move on to the second term, the B. We're going to multiply the second term times this first term. These are my inner terms. They're both on the inside here. And then this second term here by the second term here. These are both the last terms. All right. And you can see how this is repeated distribution. You can also see where they got the word FOIL, all right, which is we're going to go over it one more time. But all they did is they distributed. They took the A and distributed it to the second group. Then they took the B and they distributed it to the second group. All right. And so it's just repeated distribution. And this is just a method to remember how to do it. So this is your FOIL method, and this is an example of one. We have x plus 9 times x plus 1. My first terms are x and x, so I would multiply x times x, and I would get x squared. My outer terms, that is x times 1. X times 1, that gives me x. My inner terms, my inside terms, 9 times x gives me 9x. And then my last terms, 9 times 1 gives me 9. All right, so basically all of these are being added together. You're taking x squared plus x plus 9x plus 9. Those are my terms. Do you think this is my final answer?
No.
Why wouldn't this be? This is not in standard form, is it? It's not standard form because I have some like terms that I can combine. My like terms are these right here. And so you would keep going and you would say, well, I have x squared. That can't combine with anything. I have 1x and 9x. And then I have this 9 that cannot combine. And that would actually be my final answer, my most simplified answer of what happens when I multiply these two binomials by that method. It is just repeated distribution. And the FOIL method is just to help you remember that you've done every piece of it. First, outer, inner, last. All right? X plus 2 and x plus 6. So we are going to take this and we are going to do the FOIL method. We're going to take my first term and multiply it by my first term. X times x. And then we are going to take my first term, or outer term, which is my first and last. So outer term, x times 6. Then we are going to multiply my inner terms, 2 times x. And then we are going to multiply my last terms. That's 2 times 6. All right. Then we're going to simplify these. X times x is x squared. X times 6, we would write that 6x. 2 times x, we would write that 2x. 2 times 6, we write that as 12. All right? I'm not quite done. I need to combine my like terms here. So x squared doesn't have anything to combine with. My 6 and my 2x become 8x. My 12 also doesn't have anything to combine with. And that is my answer. For this, they want us to multiply y plus 6 times 4y minus 9. All right? So we are going to do the same thing we did before. We're going to say first term times first term. All right? Now here's where we pay attention to your positives and negatives. I have a positive times a negative. Do you think I'm going to put a plus there or a minus? A minus, because a positive times a negative is a negative. And so that will take care of what happens, and then I just have to worry about the terms themselves, y and 9. All right? Inner terms, positive 6 times positive 4y. Positive times positive is a positive. And then I have a positive 6 times a negative 9. What is that going to be? Negative. All right? Does everybody see how I'm deciding if I'm doing plus or minus in between my terms? Okay? I'm deciding based on what I'm multiplying together. And then I'm going to simplify these. So y and 4y, that is 4y squared. Minus, we're going to write this as a 9y. Plus 6 times 4y, 24y. Minus 6 times 9, 54. All right? And then I'm going to combine my like terms. Once again, pay attention to your positives and negatives. The 4y squared, that cannot combine with anything. Now I have a minus 9y and a plus 24y. So if I combine those, a negative 9 and a positive 24 are going to give me a what? Positive 15. So apply your rules of adding and subtracting positives and negatives there. And then my minus 54, that cannot combine with anything. And that is my answer. 4y squared plus 15y minus 54. Let's look at this one. In this case, my negative is in my first one. You're going to do the same process as we did before. We're going to multiply my first terms. 3a times a. My outer terms, positive times a positive. Am I going to put a plus or a minus here? Plus, so I have a positive. Inner terms, I have a negative 5 and a positive a. Is this going to be a plus or minus? A minus, yes, negative. And then my last terms, negative 5, positive 3. Is that going to be a plus or minus there? Minus. All right, and then I'm just simplifying. This is 3a squared. This is 9a. 5 times a. And 5 times 3. And once again, I need to combine like terms. 3a squared doesn't combine. Positive 9 and negative 5, what does that give me? Positive 4. And then the negative 15 does not combine. we've seen that they can write these in this method where they have two binomials. And they can actually write one in a different way. If you look at example 4, you see that it says to multiply 2x minus 5 squared. All right, so the tendency that most people do when they see this is they take this first guy and they square it, and they take the second guy and they square it. And that is not correct. Think about what it means to square something. If I tell you to take 3 and to square it, you would say, well, that is 3 times 3, okay? And so if I tell you to take a binomial and square it, then what I want you to do is I want you to take this binomial and I want you to multiply it by itself. So you're going to take this and you are going to write it twice so that you have 2 of these, and then you're going to FOIL just like you would. And so when it is something squared, you are going to multiply the binomial by itself. So you're going to take this and you're going to say 2x times 2x, 2x times negative 5, negative 5 times 2x, and negative 5 times negative 5. And then simplify as you would. 4x squared minus 20x plus 25. And so common mistake here is to not write it out twice. You want to make sure that you are listing these twice and doing your FOIL method. So go ahead and try one of those. So we will get to the point this year where we will actually be able to solve for x, but this is just actually setting it up. So a rectangular swimming pool has sides that are in a ratio of 3 to 2. If the pool is surrounded by a 5-foot wide concrete walkway, write a polynomial expression for the total area of the pool and the walkway. All right? So the first thing we're going to look at is the area of the pool. The area of the pool, we have a base of 3x and a height times 2x. Hopefully you will remember your rectangles. So rectangles are just base times height. But they don't want more than just this. They actually want the area of the entire thing. So if I take this 3x, I also have a 5 here and a 5 here that I have to add to it. So we have 3x plus 10. That's how they got this whole width across here. So the whole width is going to be 3x, which is this, plus the 2 5s, plus the 10. And let's look at the pool up and down. So the height of the pool here is 2x. We can see that right there. But again, they have 5 feet and 5 feet on either side. So they got the entire height as 2x plus 10. All right? So we got the entire width as 3x plus 10, the entire height as 2x plus 10. If they want that area, I need to multiply these two. They're both binomials. So in order to do that, I am going to have to set it up like this. All right? And then I'm just going to FOIL. So I'm going to multiply my outer inner, and last. Combine my like terms. So what they wanted us to do was just set up an equation that if we knew what x was, we could figure out what the area of both together. And so this would be an equation that represents that area. This equation represents the area of the entire pool plus concrete sidewalk that goes around it. But we would use this then to solve for what the area would be given the fact that we know what x is. All right, so let's look at one of those and then we're going to move to section 5. So if you need to draw it, anytime you have one of these, you want to draw a rectangle. If it is 40 yards longer than its width, I would say, well, I don't know the width. I'm going to write an x. How would I write 40 yards longer? X plus 40. And then you want to consider the fact that there is a 5-yard wide border that goes all the way around the entire field. So then you would change from x and x plus 40 to include that 5-yard and come up with the two sides to come up with the two binomials to multiply. All right.